Today's lesson should be a review, but this is going to be a quick discussions of atoms and ions as we start getting ready for our next unit on energy and looking at batteries. So, first thing you need to know is the difference between these two terms. So we're going to compare an atom to an ion. Now, they are related. An atom is a neutral atom. Neutral meaning it has no positive or negative trait. So in the world of magnets, an atom is plastic. It's a real thing, it exists, but it doesn't interact in that field. Compare that to an ion, which is charged. So it's not neutral. It has a positive or a negative trait. The reason we have these differences is in an atom, our positive particles, which are protons, are equal to our negative particles, which is our electrons. So everything is balanced out. And just a reminder of some of our important terms around the atom and these subatomic particles. Protons exist in the nucleus, which is the small, dense center of an atom. Around that nucleus, there are rings. The rings I'm going to be drawing as dotted lines. And those rings hold electrons. You're not responsible for memorizing this, but just for your knowledge, that first ring is little. It can only hold 2 electrons. Second ring is a little bigger. It can hold 8. Third ring is even bigger still. It could hold up to 8, but for our purposes, we're just going to put 3 in there. 1 at the top, 1 at the side, and 1 at the bottom. And we have a drawing of an atom. Now, the parts we care about the most, that outermost shell. So whichever shell is on the outside here, it's shell 3. This is our shell that actually interacts with the world and will eventually be where our electrons change and form ions. Because it's special, we give it a special name. This is our valence shell. And again, valence just being a sciencey word for outside. On that valence shell, we have our electrons that are likely to interact with the outside world. They are also special. Here I have 3 electrons, which means I would have 3 valence electrons. Because we care so much about those valence electrons, we had learned a shortcut. It's the element symbol surrounded by the number of valence electrons we have. Here it's 1, 2, 3. So I put 1, 2, 3 dots around my symbol and get my Lewis dot model. Again, quick review of important terms. Valence shell is on the outside. We care about that shell because it's the shell that interacts with the world. It's the shell that's involved in ion formation. The electrons on that shell are called valence electrons. And when we only draw valence electrons, we indicate that by putting the symbol in the middle and making the structure called the Lewis dot structure. Now, in an ion, everything is not balanced. Our protons are not equal to our electrons because our electron number has changed. Electrons have either been gained or lost. in order to make 4 full shells. This is to maximize their stability. A full shell is the most stable arrangement for an atom becoming an ion. Generally, a full shell is 8. The exception being that first ring that only holds 2, but for our level, knowing it's generally 8 is going to be right more often than not. Okay. Now, what does that mean? We're going to draw this out visually. We're going to draw the ion formation for magnesium. This is not something you are able to do independently. You would be doing this with teacher support. So if you're wondering, how in the world would I know this? You're knowing this because I'm telling you the given structure. Magnesium is similar actually to the atom we drew above. It has 3 shells. It is element number 12, which means in the neutral atom, which is where we're going to start our drawing at, our protons are equal to our electrons. So if I have 12 protons, I need to place 12 electrons. 2 dots in the first ring, 8 dots in the second ring, representing 8 electrons. So far I've drawn a total of 10 electrons. I have 2 more to place. 1 on the top and 1 on the side. This is not a very stable atom. Its current valence shell is shell 3. And if I wanted to fill shell 3, I would need 1, 2, 3, 4, 5, 6 more electrons. That's a lot. So magnesium is going to form a positive ion. It does this by kicking out the 2 electrons that are currently in its valence shell. So I'll give them little stars. These guys are leaving. My nucleus is still intact. My first ring didn't change. I still have 2 electrons in that first ring. My second ring didn't change either. I still have 8 electrons in that second ring. My third ring changed completely because it's gone. I've emptied out that third shell, which means shell 2 is now my valence shell. And this shell is full because it has my magic number of 8 electrons. Because I lost 2 negative particles, when you take away negative electrons, what you're doing is taking away negative 2 charges. Minus minus 2 cancels out. I am going to form a +2 ion. We've also drawn this the shortcut way before. Magnesium has 2 electrons in its valence shell. Those electrons leave. And it becomes magnesium +2. Yep. Nothing new. Just a quick review. See? The inverse of that would be a negative ion. So that's the pathway we're going to draw next. We're going to draw the ion formation for fluorine, which is element number 9. All right. Number 9 starts with the nucleus. And I need to place 9 electrons now. 2 in the first ring. And then I need to place 7 more in that second ring. And now you can see the fluorine atom, it's almost full. Its valence shell is shell 2. There's 7 electrons in that shell. It only needs 1 more. So when fluorine becomes an ion, it's not going to dump electrons because it doesn't need to empty a shell. It's going to gain electrons. It's going to pull an electron in and add it to its current setup. You're not going to edit those inside shells. So that inside shell is still going to have 2 electrons, but that outside shell is going to change. It started with 7. I added 1. Now I have 8. And I can see that valence shell, which is shell 2, full happy 8 electrons, and everything's going to be inverted. When you add a negative particle, you're going to become more negative. So you become a -1 ion. Okay. And our shortcut here, not much of a shortcut, but you don't have to draw all the rings. We started with 7 valence electrons. We gained 1 into the system and became a negative fluorine ion. Positive and negative ions are important terms as we move forward and start learning more about electricity and electron flow. Positive ions are referred to as cations. While negative ions are referred to as anions. Cation being that positive, meaning you lost electrons. Anion being that negative, meaning you gained electrons. Okay. Now, that's all for the notes, but I want you to use these notes to finish some quick sentences as a little bit of a checkpoint. So, at the bottom page, bottom third, you're going to do a written summary. And you're going to fill in the blanks of three questions. Not questions, statements. A or and blank is an atom that has gained or lost electrons. Fill in the blank. You can pause the video if you need. When electrons, or an electron, it could be plural or singular, are lost, a blank, and this is going to be a charge. I want either a positive, I want you to write either positive or negative, cation is formed. And then similar for number 3, but invert it. When electrons, singular or plural, are gained, a positive or negative anion is formed. Okay? So use the video and your notes above to fill in the blanks to these 3 questions.